Okay, to prove question 10, we're not proving any theorem or postulate, so we can use all the postulates in this entire section, including corresponding angles, postulate, alternate interior, alternate exterior, and consecutive interior. So when we look at this, we're given that line L is parallel to line M and line P is parallel to line Q. So that's given, and that's important to note because now all of those special angle pairs do have the relationships I just referenced, in that alternate interior, alternate exterior, and corresponding angles are all congruent, and consecutive interior angles are supplementary. Now what we're trying to prove is that angle 1 is congruent to angle 2, which simply means that their measures are equal. But because we're proving that they're equal and that they're not supplementary, we're probably going to stay away from consecutive interior angles. Now as I go to prove this, I need to get 1 into the proof and I need to get 2 into the proof. And deciding how to get them in is kind of important, because we want to get them in so that the piece that we use to get 1 in can be the same piece that we use to get 2 in. The same relationship we use to get 1 in is the same relationship we can use to get 2 in. Now in the previous proof, if you watched it, a very important skill is that you understand you can name these angles using numbers. I guess you could put vertices on them if you wanted, but it's easier just to number them, and you can use them in the proof. Now as I look at 1, I see that 1 could be related to 3, okay, because those are corresponding angles, and corresponding angles are congruent if the lines are parallel, which we know that they are. And 3 can be related to 2 because they're alternate interiors. So that's one way that we could go. Another way that we could go 1 to 4 alternate exterior and 4 to 2 corresponding. Now if you wanted to, because you know these lines P and Q are parallel, you could actually extend this and you could put angle numbers over here. So we could put a 5 here. 1 and 5 are corresponding, 5 and 2 are alternate exterior, or if you really wanted, you could say 1 and 6 and 6 and 2. But there are a lot of ways you can go. We only have to pick one. And you can really use any of these angles you want. You don't want to put an angle over here. 7's not related to 1, and it's not related to 2 by any of those special angle pairs, and that's really the way the rest of them go. I guess we could put a 7 there, and consecutive interior works, but 7 and 2 aren't related. And again, consecutive interior means they're supplementary. We want to stay away from that. So from here, I'm just going to use 3. Angle 1 is congruent to angle 3 because those are corresponding angles. Don't know why I wrote that out. It's actually a postulate, but I'm running out of space. And then from there, so 1 is in the proof. I want to get 2 in the proof, and if possible, I want to get into the proof using angle 3, because then we can use those to connect those through substitution. And I can say that angle 2 is congruent to angle 3 because they are alternate interior angles. Again, it is the postulate. And then if I look here to prove that angle 1 is congruent to angle 2, I can use this statement, angle 1 is congruent to, but instead of putting angle 3, I can substitute angle 2 because they're congruent. I guess I really didn't need to write that again. Let me just take this and drop it all the way down in here. And that is true by substitution. Again, if you've watched all these videos, hopefully you're realizing that you have to have a very strong idea of what these angle pairs are and when they are congruent and when they're not, and be able to use the vocabulary very quickly and readily and efficiently. So that's the proof for 10. Again, the proof for 9 is also there, and questions 1 and 2 are there as well.